Hi everyone, this is Teacher Justina and welcome back to my channel. If you are new, then do not forget to like, share, and hit the notification bell for more video updates. And also, please do leave your comment below. Our topic for this video is all about finding the number of terms, or the unknown is the number of terms in an arithmetic sequence. But this is already involved an algebraic expression. Okay, so let us try this example. How many terms in this sequence? X plus 1, 2x plus 2, 3x plus 3, 4x plus 4, and until 10x plus 10. As to what term is 10x plus 10? Let us try C and have the given data. So our first term is x plus 1, and then our common difference is x plus 1. Let us try check why we're able to get the common difference of x plus 1. Okay, so we have the second term minus the first term, so we have 2x plus 2. Okay, our second term minus our first term, which is x plus 1. And to further simplify, we have the 2x plus 2, and then that negative will be distributed. That will become negative x, and that negative times positive 1, we have a negative 1. And next is we are going to combine similar terms. 2x minus x, we have an x, and the positive 2 plus negative 1 is equal to positive 1. So we have the x plus 1 as their difference. Let us try another. The third term minus the second term. So our third term is 3x plus 3 minus our second term, which is 2x plus 2. So this will be equal to the 3x plus 3, then minus that negative will be distributed to the quantity of 2x plus 2. So this will become negative 2x, and then negative times positive 2, we have a negative 2. And then to further simplify, the 3x minus 2x, we have an x, and a positive 3 plus negative 2, we have a positive 1. So it is already a proof that our x plus 1 is a constant difference. So therefore, our common difference is x plus 1. So let us proceed. So using the formula, a sub n is equal to a sub 1 plus n minus 1 times the d. So let us now substitute. Our a sub n is our a sub n is 10x plus 10 is equal to our a sub 1 is equal to x plus 1 plus n minus 1 times our common difference, which is x plus 1. Next is we are going to transpose the quantity of x plus 1 to the left. So that's it. So what are the terms on the left? We have the 10x plus 10 minus the quantity of x plus 1. And the remaining on the right sides are n minus 1 and x plus 1. So the next step is we will be removing the parentheses by distributing negative 1, uh, or understood negative times x will be negative x, and negative times positive 1, we have a negative 1. And the remaining term on the right sides are n minus 1 times x plus 1. Okay, so to further simplify, we have the 10x and the negative x can be combined, and the positive 10 and negative 1. So we have the next step. So 10x minus x, we have 9x, and the positive 10 and the negative 1 will gives us a 9. Okay, so again, we have to rewrite the n minus 1 times the x plus 1. So we will be getting the value of our n. So far, we will leave the n minus 1 term on the right, and the x plus 1 should be isolated. But in what way we can isolate the x plus 1 is by using uh, by uh, by factoring first on the left side. So 9x plus 9, the common factors or the common monomial factor is 9 because 9 can divide 9x. At the same time, this 9 can divide 9. So therefore, the 9 is common. So that 9x divided by 9 will gives us x, while 9 divided by itself, we have a positive 1. Then it is equal to n minus 1 times x plus 1. So therefore, we are going to get the value of n, and this n minus 1 term should be left on the right side, and we are to isolate the x plus 1. But in what way we can isolate the x plus 1 term? Is by using the division property of equality. So we will be isolating the x plus 1, thus our common divisor to both sides are x plus 1. So as you have seen on the left, starting from the left, the x plus 1 is common. So this is x plus 1 divided by itself, and then the x plus 1, that's it, and the x plus 1 on the right, as the numerator is same with the denominator, thus we're able to answers this 1, and this also answers 1. So the remaining term on the right is 9, while the remaining term on the right is n minus 1. And since we will be getting the value of n, that negative 1 will be transposed to the left, and that will become a positive 1. So 9 plus 1 is equal to n. So therefore, the 10x plus 10 is the 10th term in the sequence. So again, our n is equal to 10. So there are 10 terms in the sequence. So let us try check if the 10x plus 10 is really the 10th term in the sequence. Okay, let us try count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and our uh, 10th term. Okay, so I hope it is clear that this number 1, our n, is equal to 10. Okay, so let us have this example. How many terms are there in the sequence? Negative 3m plus 1, negative m plus 1, m plus 1, 3m plus 1, until the last term, which is 9m plus 1. As to what term is 9m plus 1 in the sequence, so let us have the different given data. So our first term is negative 3m plus 1. Our common difference is 2m. And how did we get the common difference 2m? So let us try. So it is already known that getting the common difference, second term minus the first term. So we have the second term, which is negative m plus 1, minus our first term, which is negative 3m plus 1. And thus we have the negative m plus 1, this one. And we will be simplifying the negative, distribute it to the quantity, to the terms inside the parentheses, so that will become positive 3m, because negative times negative and negative times positive 1, we have a negative 1. And to further simplify the similar terms, negative m plus 3m, we have 2m. Then the positive 1 and the negative 1 will give us a 0 already. And done subtracting second minus first. Let us now have the third minus second. So the third term is m plus 1 minus our second term, which is negative m plus 1. So removing the parentheses of m plus 1, then the negative times the negative, we have a positive m, and the negative times positive 1, we have a negative 1. So far, the m and the m here are similar terms, thus we can combine them. So this will be 2m, while the positive 1 and the negative 1 will give us a 0. And so far, the difference is consistent to have 2m. So therefore, our common difference is 2m. Let us now find the n, or the number of terms. So to substitute to the formula, our a sub n, our last term refers to the 9m plus 1, and our first term is negative 3m plus 1 plus n minus 1 times 2m. So the next step is we will be transposing the negative 3m plus 1 to the left. So therefore, we have the 9m plus 1. The negative 3m becomes positive, while the positive 1 becomes negative 1. So the remaining terms on the right are n minus 1 times 2m. Okay, so for the next one is we will be combining the 9m and the 3m, which is 12m. The positive 1 and the negative 1 will be already a 0, and still n minus 1 times 2m on the right. And this time, we will be uh, getting the value of n, but the n there, the n minus 1 has a multiplier of 2m, so we want to isolate the 2m so that our remaining term is n minus 1 and there is the n. So therefore, to isolate the 2m, we will be dividing both side by 2m. Okay, so therefore, it is already divided both by 2m. Why 2m? Because the n minus 1 is with the 2m. So therefore, 12m divided by 2m. Okay, that's 1. So 12 divided by 2 will gives us a 6. While in here, the 2m divided by 2m will gives us 1 already. So therefore, the remaining there on the right is n minus 1. And since we will be getting the value of n, so therefore, that negative 1 will be transposed and 6 plus 1 is equal to n. And therefore, our value of n is equal to 7. So meaning uh, that 9m plus 1 is the seventh term in the sequence. Okay, so guys, I hope you've understood our topic for today's video. And if you want to learn more, please do leave your comment and do subscribe and hit the notification bell for notification. This has been Teacher Justina, and thank you for watching. That in all things, God may be glorified. Goodbye, everyone.